Hi everybody. So in this video we're going to look at solving trigonometric equations involving quadratics. So in this question we've been asked to solve sine squared x minus sine x equals 0 within the range of 0 to 360 inclusive. So because we have a sine squared x term and a sine x term, we can treat this like a quadratic. We can factor out the sine x and then we'll multiply this by sine x minus 1. Thus, can you see that when we multiply this sine x by this sine x, we get the sine squared x, and then when we multiply the sine x by the negative 1, we get negative sine x. So now to solve this equation, we need each of these terms to equal 0. So our solutions will be when sine x equals 0 and when sine x minus 1 equals 0. And then to find the x values within this range, we need to sketch a sine graph. So we've got y equals sine x here, and to find the value when this equals 0, well, this will be at this point, when x equals 0, when x equals 180, and when x equals 360. So these will be three of our solutions, 0, 180, and 360. But we have another solution when sine x minus 1 equals 0. We can move this negative 1 to the right-hand side, so sine x will equal 1, and this will be when x equals 90 degrees. So x equals 90 will be the other solution. So you can see that this equation has four solutions at 0, at 90, 180, and 360 degrees. Okay, let's try another example. Okay, so in this example, we've been asked to solve the equation 2 cos squared x minus sine x minus 1 equals 0. Again, within the range of 0 to 360. So now we have a combination of cos and sine terms. And to take this further, we need to change this so it involves only cos or only sine. And we can use sine squared x plus cos squared x equals 1 to write this cos squared x in terms of sine x. So we'll move the sine squared x to the right-hand side. So cos squared x will equal 1 minus sine squared x. Then we can substitute this in place of the cos squared x. So we've got 2 lots of 1 minus sine squared x minus the sine x minus the 1 will equal 0. We can expand out this bracket, so 2 minus 2 sine squared x minus sine x minus 1 equals 0. And then we can treat this like a quadratic equation, where we'll make this term positive, so we get 2 sine squared x. We'll move this to the right-hand side, and then with 2 minus 1 is 1, on the right-hand side this becomes negative 1. And then we can factorize this, so we get 2 sine x minus 1 and sine x plus 1. So our solutions, making each of these brackets equal to 0, will be sine x equals 1/2 and sine x equals negative 1. To find the values of x within this range for each of these, we need to sketch a graph again. So if we look at the sine x equals 1/2, we can take the arcsine of both sides, so x will equal the arcsine of 1/2, so x will equal 30 degrees. We can mark this on our sine graph at about here, and you can see that this will have two solutions, one at 30 degrees and one at this point. And because it's symmetrical about 90 degrees, it'll be 30 from 180, which will give us our other solution of 150. And then for sine x equals negative 1, this will be at this point, where you can see that x is equal to 270. So there'll be three solutions where x equals 30, 150, and 270 degrees. Okay, let's try one more example. So in this example, we've been asked to solve 10x equals 4 cos x within the range of negative 180 to 180 inclusive. Again, we've got a combination of tan and cos, and we need to reduce this to one trigonometric term. But we know that tan x will equal sin x over cos x. So we can replace the tan x with this. So we get sin x over cos x will equal 4 cos x. Then we can move this denominator to the right-hand side. So this will give us 4 cos squared x. And then we can use the Pythagorean identity to write cos squared x in terms of sin x. So cos squared x will be equal to 1 minus sin squared x. Then we'll substitute this into here. So sin x will equal 4 lots of 1 minus sin squared x. We'll multiply out these brackets. So sin x will equal 4 minus 4 sin squared x. And then we'll make this equal 0. So we get 4 sin squared x plus the sin x minus the 4 will equal 0. And then we can solve this quadratic on our calculators. We'll go to menu. We'll choose the equation solver. We want polynomial to the second degree. We've got 4 sin squared x, 1 as the coefficient of sin x, and the constant term is negative 4. So our solutions is that sin x will equal 0.883 and sin x will equal negative 1.13. Now we know that this is not a valid solution because sin x has a range from negative 1 to positive 1. So we'll just say that this is not valid. So to find the solutions to this, we need to sketch the sine graph again. If we take the arc sine of both sides, then x will equal the arc sine of 0.883, which is 62 degrees, which will be about here on our sine graph. So within our range of negative 180 to 180, we'll have two solutions, one at 62 degrees. We know this is 28 degrees on this side, so 28 degrees on the other side will give us 118 degrees. So our solutions are x equals 62 and x equals 118 degrees. Okay? Well, thank you very much for watching. I hope you found that useful. If you did find that helpful, please like and subscribe. And you can download a full lesson and worksheet from my website, mrmathematics.com. There's a link in the description below.